Okay, let's look at the second derivative test for absolute extrema. Right? Here's how it goes. Let the f be a continuous function on some interval I, and c be the only critical value of f on this interval I. So you have only one critical value, right? Then if first derivative at the critical value is equal to 0, so derivative equal to 0 there, and the second derivative is positive, right, which means that you have a concave up shape, then f of c is the absolute minimum on I, all right, not just a local minimum, it's actually the absolute minimum, right? Another one, if the derivative at c equal to 0 and the second derivative happens to be negative at c, then, so which means that you have a concave down shape, then f of c is the absolute maximum on that interval I. All right, so it's very similar to second derivative test for local max and local min. Then only thing that's different is here. This is the only critical value on that interval. All right, so let's look at an example here. All right, so we want to find the absolute maximum value of this given function on this interval here. It's not a closed interval, it's an open interval from 0 to positive infinity. All right, so let's find a critical value first. So we take the derivative, so f prime of x is equal to, right, derivative of 20 is 0, derivative of negative 3x is negative 3, and the derivative of negative 12 over x, let's see, we have to rewrite that first. Right, so this guy is same thing as negative 12 x to the negative 1, right? So the derivative is going to be, put negative 1 in front, so that's going to be a positive 12. Then subtract 1 from the power, so x to the negative 2, right? So this is negative 3 plus 12 over x squared, and set that equal to 0, right? We can add, well, first I'm gonna just, let's see, add the 3 to both sides, right? So that's going to be a 12 over x squared is equal to 3, and take the reciprocal of both sides, then you get x squared over 12 is equal to 1/3, and then multiply both sides by 12, you get x squared is equal to 4, right? Then take the square root of both sides, we have critical number x is equal to plus or minus 2, right? Square root of 4. So these are critical values, right? But there's only one critical value is on from 0 to infinity. That is just a positive 2, right? So this is the only critical value on that interval, right? Right, so it satisfies that condition, and f is a continuous on that interval, so that satisfies the hypothesis there. All right, so we have to look at the second derivative to do this test. So we take another derivative, so f double prime of x. Derivative of negative 3 is 0, so I'm not going to write anything down. Derivative of 12x to the negative 2 would be negative 2 times 12 would be 24. X to the, subtract 1 from the power, so to the negative 3 power, right? Which we can rewrite it as a negative 24 over x cubed, right? But all we care about is a sign when at the x equals 2, which is a critical number. So let's do that. Let's evaluate f double prime at the critical number, the only critical number 2, right? So you have a negative 24 over, right? So 2 cubed is 8. That's going to be negative 3, right? So which is negative, right? Which tells you that it's a concave down shape. Then we know that it's going to be the absolute maximum. So absolute maximum value is f of 2. So plug into the original function, 20 minus 2 times 3 is 6, right? And negative 12 over 2 would be negative 6, right? So that's 20 minus 12, so that would be 8, right? So this is the absolute maximum value, and we know that from the second derivative test. Right? That's how we apply second derivative test. Right? That's it. I hope that this was clear.